Today's well-ventilated oceans rely on the planet having ice at the poles. It's here that warm, salty water flowing up from the tropics cools down, takes on oxygen, and sinks back into the depths to begin the return journey. This is the engine that drives ocean circulation.
The ocean mixes itself on the order of every 500 years or so, and it's that mixing process that brings oxygen into the deep sea. The warming that takes place as a result of the buildup of carbon dioxide is more dramatic at high latitudes. The supply of oxygen depends on there being cold water there. Warm water doesn't hold large amounts of oxygen in it, and so to provide oxygen to the deep sea requires cold waters where these waters are sinking.
In the lead up to a super greenhouse, there was no cold water at the poles. With both faltering currents and over-fertilized surface waters, the stage was set to push large areas of the global ocean, first into runaway anoxia, and then into something far more dangerous. Remove all the oxygen from the water, and deadly poisonous hydrogen sulfide will start to spread upwards from the stagnant depths.
There's evidence that during these oceanic anoxic events, you actually had that happening within these broad super oceans. So the whole of the Pacific might have been euxenic, as we call it, devoid of oxygen and containing free hydrogen sulfide. So these very noxious environments spreading over huge areas of the globe.
The best way to understand just how bad things can get during an oceanic anoxic event is to go for a swim in. And you can, on a small scale at least, in upstate New York. Lee Kump offered to take a dive into oil's poisonous prehistory.
Green Lake's a fantastic place because it's a mesocosm of what Arctic oceans might have been like in the distant geological past.
Dropping down from the surface, Green Lake at first seems quite normal. But then it changes.
You're moving down through 15, 18 meters, the water's getting darker. There's obviously some suspended bacterial life in the water. But around 20 meters, you end up in an environment that's highly poisonous because not only is it free of oxygen, but it also has toxic levels of hydrogen sulfide. It'd be a horrible place for any air-breathing organism to live. If you have a bright enough light, you see that this murky color suddenly forms itself into this pink or reddish color.
This is no place for a human to linger. The colour comes from the few organisms that can survive in this hydrogen sulfide-rich water. Purple and green, sulfur-eating bacteria.
Purple sulfur bacteria are photosynthetic. They need light, but they also need hydrogen sulfide and they stand oxygen. So they live right at this transition between oxygenated and sulfidic water, where both of the things that they find essential are available.
Beneath this thick band of bacteria, the lake turns pitch dark and deadly. A perfect tomb for organic carbon.
That environment, we think, was what the deep ocean was like in these oceanic anoxic events.
Scale Green Lake up to the size of the planet, and it's easy to see how broad swathes of the ocean became a giant plankton graveyard. a graveyard into which every dead or dying organism sank without decay. This is what was so special about the major episodes of oil formation. The oceans were dying from a double whammy of suffocation and hydrogen sulfide poisoning. And for as long as sulfur bacteria thrived in the sunlight, many other life forms faced extinction. This was a world with the entire seafloor stagnant and littered with corpses. Whole coastlines stinking of rotten egg gas and death. But here's the twist.
Essentially, the system sort of sows the seeds of destruction because as you bury the organic matter, essentially you're entombing carbon dioxide. So carbon dioxide in the atmosphere and the ocean, they're always exchanging, is drawn down and the greenhouse effect goes into reverse. The world cools and the oceanic event switches itself off and you're back to equilibrium. And over a time scale, I would say, of maybe 250,000 years, something like that, from the switch on point to the switch off point. So the whole thing comes into a beautiful full circle, and you can see this anoxic event as a way that the Earth reacts to removing the excess carbon dioxide that's vented into the atmosphere.
Of the handful of such events now identified, every one shows the anoxia switch on sharply, as if some threshold of warming is suddenly crossed. And equally suddenly, they switch off when enough carbon has been buried to cool the planet. The burial of excess carbon resets the Earth's thermostat. There is a sharp drop in sea temperature, a drop in sea level, and signs of ice reforming for a time at the poles. And the legacy for us? Another oil deposit entombing all the carbon that caused the problem in the first place.
We find the oil, we burn the oil, we push carbon dioxide back into the atmosphere, and essentially we push the planet towards a greenhouse future.
Of course, crude oil is only one source of the fossilized carbon we're adding to the atmosphere. But it's crude that allows us to mine coal so easily, and crude source rocks that produce our natural gas. It's crude that has allowed us to clear forests and spread out over the surface of the Earth with such speed and in such numbers. It's crude that underpins the growth that keeps economies solvent. In short, crude drives the civilization that pumps the gas.
If you look at the historical records of the atmospheric CO2, you can see us undulating along in the last ice age, coming out of the last ice age, and then coming up towards the present, and you reach the last century, and suddenly this spike goes through the roof. And it is probable that the Earth has never experienced a increase of CO2 in the atmosphere at anything like this rate in its history.
It's a rate that might be ushering in not just global warming, but the next super greenhouse. The evidence suggests that the overcooked worlds of the past were triggered by levels of CO2 about 4 times higher than those at the start of our industrial age. But while it took volcanoes thousands or even millions of years to achieve these levels, we're about to reach them in